All right, welcome back, guys. As I said before, we are going to talk about creating a standing wave. I think this is going to take more than about 2 minutes, so we're going to make a separate video for it. Okay, so imagine we have two waves on a string. String 1 is right here, and it's moving to the right. And string 2 is right here, and it's moving to the left. Okay, and these two strings are going to move towards each other, and they're going to overlap. And when they overlap, they start interacting with each other. Okay, so what we have here is we have a moment when string 1 and string 2 are close to alignment, but are not quite aligned. We start adding up the amplitude of right here, and right here, and right here, and right here, and right here. And what we get is this wave that, let's pick a point, say right here. I pick a point right here. This wave here has got kind of a slope this direction that's going upwards. This one here got a slope going upwards. We add them together, and they're going to add up to something greater than each one was individually. But we definitely are not lining up our peaks. If our peaks line up and our crests line up, then we're going to get the maximum amplitude. So notice this one here, if I add them together, has got taller peaks and valleys than this one here did. On the other hand, let's say they've shifted such that they're 180 degrees out of phase. Okay, they're 180 degrees out of phase. So this one's minimum, this one's maximum add up together. This one's minimum, this one's maximum add together. And we add up all of these lines, and they're going to cancel each other out and give us just a flat line. Okay, so we're going to look at this in a little bit more detail. We're going to have figures with two sets of lines. One is orange and one is red. Okay, and we're going to have a blue line that's going to be the sum of adding up the red line and the orange line. Okay, so we have these two waves, and we have this red one, we have this blue one, and they're not quite exactly lined up. So imagine we have a rope, we're shaking a rope, and like they're going down one side, we take a photo of it. And we have one going the other way into the rope, we take a photo, we take those two lines, we add them together. That's what we've got going on here. So one is the red rope, one's the orange rope. We're adding their two waves together, we get this blue line. So we take this point right here. Our orange line is at 0. So which means a 0 plus our red line gives us this point right here on the blue line. On the other hand here, like at this point, our orange line and our red line's at 0, our orange line's not at 0, we add the two together and we get this value here on the blue line. And so we add these two together, and they're adding up to each other in a way that is greater than, our max height here is greater than the height of either of these two. Okay, now they have shifted phase a little bit, and now we're 1/8 of a period different from where we started from. And in this case, it just so happens that our amplitudes line up. The amplitude of the red one, the amplitude of the orange one are the same, and so we get the largest displacement. Okay, another 1/8 of a period goes by. Now we're no longer quite lined up to each other, they're shifted a little bit, and every time that our maximums are going to line to the 0 point. Okay, so we get this region here in the middle where both things are non-zero. This is actually our highest amplitude. Okay, go a little bit further, another 1/8 of a period in, and so now we are going to have the red one and the orange one 180 degrees out of phase each other. So we add them together and we're going to get 0. So we're going to get here. We're going to get the 0 value here because they're out of phase. So we get this point here, the 1/8 where they're in phase with each other with the largest amplitude. We get the point where they are 180 degrees out of phase with each other. We get the minimum amplitude. And in between, we're going to have some values that are kind of in between the two values. Okay. We can continue the same pattern with the rest of the oscillations. As we shift over further, step them further and further out of phase with each other, so they're 5/8 of a period out of phase, we once again come back into alignment right here. We go to 7/8, cancel out, and this pattern just repeats. We keep shifting it over, so we have one full period, we're back to where we started from. Okay, so this is the end of the standing wave part. If you have questions, please let me know. Please come visit me in office hours and have fun with this stuff.